Hello, everybody. Welcome. Nice to see you. Thanks for understanding the very short delay as we get started today. I obviously saw one question. Someone says, is the screen shaking? Yeah, so the video at the start of the lecture is a video I took. And I actually took it for a lecture. I was actually at a waterfall and I was like, this would make a beautiful lecture standby screen. And I didn't realize when I was kind of filming, because I was like, it's a nice loop, because waterfalls, it's hard to tell when it starts. But yeah, I did bump the camera at one point. So it kind of every now and again shakes a little bit. But just before I start the kind of proper recording, just saying a big hi. We got 60 people here. That's about, what, 7% of the course? So hello, if you're tuning in live, obviously. It's always lovely to chat to people that I know are, sitting there actually watching stuff today. But we'll get kind of... Oh, you were joking. That's funny. Cinder Keitel. Okay. Hello. I don't know why it crashed on me there. I'm sorry. Sorry, everyone. Let's keep going. Okay, so today We are jumping ahead to lecture 4.2. If you've looked at the course website kind of prior to like Tuesday morning, you'll see that this is meant to be the second lecture of the week on the course website. But the plan this term from Yuchao is to bring this lecture further forward. That's a great idea from Yuchao because this lecture is really, really critical. In a lot of ways, it's probably, I would argue, it's possibly the single most impactful lecture that you will watch in the term. Not necessarily in terms of like your overall future in life or anything like that, but more that for this course and the project, the stuff you learn today, you will be kind of dealing with on a daily basis, you know, whenever you work on the course for the rest of the term, you know, so it is pretty exciting and important. It is the lecture on HTTP servers. Now in this lecture, we're going to be talking about networks, express servers, APIs, CRUD. There's actually a lot to unpack, so it's going to be a pretty dense couple of hours, and if you don't get it straight away, that's totally fine. I wouldn't stress too much. You can always kind of go back, watch the lecture again, revise it, etc. But the reason we're talking about it, fundamentally, even beyond the course, is because web servers are a fundamental part of web-based full-stack software. Okay, I don't want to spend too long unpacking that, but a lot of software these days is web-based. A lot of it, the vast majority of it. And because most of our software is web-based, you know, the things that underpin that web-based software, which are web servers, they are really important to understand because more than half of you are going to, in some way, go and interact with stuff similar to this course in your software engineering career. They are everywhere. So really, really pivotal, fundamental stuff. We're going to talk a little bit about theory first, and then we're going to go and do a little bit of coding. But if we just start off with the theory, I always love to talk about three really important words because they often get used interchangeably. And it really helps, I guess, understand what exactly is unique about, you know, like each particular word. Like as a good example, people use the word network a lot, right? And the word network has pretty much nothing to do with the internet, right? And what I mean by that is like I'm at home right now, my computer and in fact, I have two computers at home that are sharing files right now, right? I have a little Mac thing that I'm doing some work on, and I have my desktop. They're talking to each other. They don't need the internet for that. They're not using the web, as you know, your parents or grandparents might call it. They're just on a network, and a network's defined as two computers that basically can communicate together. The internet was a concept that came around after we developed computer networks, which said, why don't we just globally connect computer networks, right? Pretty simple idea. You can probably figure that out pretty quickly, because you have a network at home. The internet is just the network of the world. Pretty cool. The World Wide Web, and I think this is the part where people can get mixed up, is that the World Wide Web is a part of how the internet's used that is specifically about sharing information via URLs, is kind of how I best summarize it. That means that every time you kind of go and type in a URL to go somewhere, you're using the World Wide Web. And I think the reason that's an important distinction is because the World Wide Web is everything to do with the web browser. So if you use a web browser, like right now, right, like, or we'll see in this lecture, like even YouTube, you're probably watching this YouTube video. The YouTube video has a URL and it is using the World Wide Web to communicate. Now you might be thinking, okay, well, when do I use the internet that's not the World Wide Web? Because that's a really interesting question. We'll answer that in a sec, so have a think about it. Tell me the times you think you use the internet where you're not using the World Wide Web. But if you do want to learn more about this topic generally, you can go and study networks, right? I don't think it's a core course. It at least wasn't when I was studying. But you can go check it out if you want to learn more about networks. I'd probably generally encourage it. Like, it's not the most fun course from what I've seen, but it does teach you a lot. Like, I didn't do it, and I feel okay. But yeah, I don't know. Networks can be a really useful thing to understand. Like, software is now more than ever engaged in some kind of networking. But I also haven't looked at the course, so don't do it because I said so. I haven't done it, and I haven't really looked at it. Okay. Now, people have started answering my question about, you know, what the hell is the World Wide, what is not the World Wide Web? But to unpack that further first, when it comes to network protocols, these are the things that underpin the internet generally, or I mean, not even the internet, networks. This is why the terminology is really important, right? Because network protocols define how computers talk to each other. The internet is going to use network protocols because the internet is just a big network, naturally. So when communication happens over networks, right? Like I have a Mac Mini for work that's talking to my desktop here, which is a Windows machine. And they can share files and things together, but they need a way to understand each other. Like we kind of talked about data interchange in a previous lecture about how different systems need to talk. So we didn't really use the word protocols, but protocols are really just what underpins the rules of how two things interact. And humans do this stuff all the time, whether we like wave to each other or we clap or we handshake. Like, you know, you meet someone, you say a certain thing. When you hang up the phone, you say bye before you put the phone down, you know. We have rules of engagement that help us communicate with people of different cultures, different backgrounds, different languages, and all kinds of things like that. Computers are the same. So someone sits down and defines, this is how you're going to communicate this type of stuff, and everyone has to agree on it. And there are a bunch of network protocols. This is kind of what you would go and learn in 1531. There's a lot on this list. We're not really going to learn about them. That's why it's kind of so small. But there's a few that will look kind of familiar. The main one that people will recognize will be HTTP up in the top right. HTTP is an example of one of the protocols of how you can communicate over networks. But there are a lot, right? We have SMTP, POP, and IMAP. You might not have heard about these as much because POP and IMAP are less popular, but SMTP is a word that's thrown around a bunch. They're all to do with emails. Someone in the chat has mentioned FTP, which is a way of transferring files. I think one that isn't mentioned on this diagram that you would have seen a lot is just SSH. SSH is another protocol. It has nothing to do with HTTP, right? So that's, I guess, a hint for the question I was asking earlier. And there's lots of these different types of protocols, but HTTP is the protocol that you use to access URLs in your web browser. That's why every URL you have, basically, has an HTTP or an HTTPS in front of it. It's because it's basically saying, hey, everything after that's like information about where to find something on the internet. It's basically like an address, like I want this piece of information, but the HTTP says, this is the protocol I'm using. This is the type of communication we're going to have. And you can access files another way that isn't HTTP if you want to through another protocol. You can use SSH or SCP to use, you know, terminal and collect files over terminal. They're just different protocols at the end of the day. I've got a few random screenshots here. This is SSH, IMAP, FTP. We've kind of just talked about them. And I've got this cute little diagram up here as well that kind of just shows some different, you know, network protocols. So we've got like SMTP down here, which is for predominantly sending emails. FTP, which is uploading and downloading files. So FTP is a protocol where you could set up two computers that are on the internet, use a FTP-based program, and they would be able to send files not through a web browser, which is interesting because if you think about it, when was the last time you sent a file to someone not through a web browser, right? Probably not that often. Maybe if you have Outlook installed on your computer, it's via SMTP or something like that. But if you're using Gmail or Instagram or all of that, it's all going through a web browser. Everything you're sending it through has HTTP in front of it. And HTTP really is the basis of a lot of stuff. We could unpack some of these. If people have questions about it, you can ask and I will answer them. But by and large, we're just trying to demonstrate there's a lot of protocols out there. So the internet uses all these kinds of protocols to solve different problems. The World Wide Web uses these ones at the top, the HTTP ones, and they're the ones we're going to be focusing on today. So let's talk about HTTP. HTTP stands for Hypertext Transfer Protocol. The Hypertext Transfer Protocol is about sending and receiving HTML documents, but I wouldn't focus on that HTML part. It's basically about sending and receiving information via web browsers and web requests via URLs. You know, there's probably a very organically changing definition over time, but predominantly web browsers are the applications we use to request and receive HTTP requests. So imagine that you have a web browser, everything it's doing is getting a URL and sending it over the World Wide Web to a web server somewhere. That web server is receiving that as a request and it's giving back information. We're going to make a little web server that takes that information in. So I mentioned a web browser tries to talk to a server to get a response. we have a web browser right here. I'm using it right now. We're going to make our own server and we're going to make them talk to each other. A very popular NPM library exists that allows us to run our own HTTP server, and we can make it like that. It's one of the easiest ways to get a web server spooled up. It's built in Node.js. It's obviously hosted on npm.js. You can go to the website here. This is the actual website they've created for the server, although naturally you can always search up npm.js and Express as well. You can go find it on npm, and Yuchao should have gone through this with you when they went through the npm stuff. So, you know, very popular library, installed quite a lot, pretty standard. We're going to go and make our own. I've got a little example here with Express. You can go find examples online. ChatGPT can also generate you one instantly. If you say, like, I want an Express server, it would get it done pretty quickly. But this is a pretty little straightforward one. I'm just going to unpack the different pieces of code here. The first code is us importing the Express server. Makes sense. This next piece of code, it is creating an instance of the Express server. This idea might not make the most sense to you, but it's kind of like when you import a library like Express, what you're basically importing is like a tool that creates things. So on line 3, what I'm actually saying is like, okay, Express is a tool to create servers. I'm going to create a server. So app is now the server. Express is just a library that creates a server, in this case called app. Port is a particular port that the server runs on. We'll unpack what port is in a little bit. Everything needs a port. This line's a bit of a quirk of Express that you need to include to just capture the data as text. I wouldn't worry about it too much, just kind of treat it as one of those things you kind of have to do. I hate saying that, but you know, that's kind of what that is. Now, the next ones are really interesting. This is the part of code that actually does the web servering. In particular, I want you to pay attention to this one here. What this one basically says is that when someone tries to access the URL /hello, I want you to respond by sending the text hello with an exclamation mark. Don't worry about the one underneath for now. Then finally, this line here is really important because this is the line that actually starts the web server. This is the one that says, hey, I want you to spool up, start running, start existing. I want you to run on this port, and it will just kind of run forever until such a time that you tell it to stop. So I've got some code up here. I'm just going to go to our 4.2 lecture. I've got this server here called Express Basic. I've got my terminal up here. I'm going to go in 4.2. I'm going to npm install because, you know, I should have a package. I have a package.json there. It's got a few things in it that include the Express server. It's got a bunch of other stuff I wouldn't worry about too much. There's our Express server. This is a bit of an old sample code that the course has, I imagine. Not too old, actually. So you can see the current latest version of Express is 4.21, whereas the one that we kind of have in our package.json is 4.18. Now, just as a reminder, whilst I'm here, as a general rule, usually libraries only make significant, potentially breaking changes by upping the biggest number. So what that means is like, we should be able to pretty safely upgrade our Express, and I can do it right now. npm install Express. I can either do at 4.21.0 from the website, or I can just say at latest. And at latest will go and get me the latest version. And if I click on the right here, you'll see the number update like that, right? That's it. That's the npm program basically updating the package.json with the latest library. I can usually pretty safely assume that you know, going from .18 to .21 will be fine. But if I saw a library go from 4. something to 5. something, that's usually when engineers need to stop and be like, okay, because if they change that version, it's usually there's some stuff code you have written that you would need to change, basically. Like it would have to be a proper migration where you go and, you know, update the source code. So I've gone and npm installed that. Cool. Back to my code example here. If I want to run it, I don't think I have anything about running it here, but if I want to run it, I can simply run it just like any other piece of node. I can say node Express Basic. Let me make this a little bigger too. Oh my God, that disappeared. There we go. Okay, now I can run that. Oh, okay. Someone's missed something. You don't need to worry about this. Just whatever's in the lecture code seems to be. Oh, yes, I'm so sorry, of course. We are doing TypeScript at the moment. Very silly of me. So don't worry about what I just did then. Ignore that. That was a mistake on my end. So because we're using TypeScript now, I kind of forgot this because I didn't teach the TypeScript lecture. So in my head, I'm like, we haven't learned TypeScript yet. But if you remember from the TypeScript lecture, we have this new command called tsnode. So because this is a TypeScript file, instead of running node on Express Basic, right, which doesn't work because node's like, what the hell is all this stuff? I need to do npm run tsnode, right, because I've got the tsnode library there, and then Express Basic. Really easy change, so it's not too complicated. That'll go and spool up the Express stuff. And here we say listing on port 3000. So you notice this program isn't ending. The way to think about a web server is that it's basically a while true loop, looping infinitely. It's basically sitting there running forever, very quietly, very low overhead, just waiting and like listening. That's why they say listening, for someone to try and talk to it. So if I open up over here, for instance, I open up a new tab and I type in localhost 3000 and I run that, I get this little response here that says, cannot get slash. Now the reason I've gotten that is because if you have a look at the code itself, we have not told this web server how to deal with when someone simply asks for localhost 3000 slash. Because let's unpack this for a second. When I try and access this, firstly, localhost refers to this computer. Normally on the internet, we use a term like Google or unsw.edu.au. But when we're developing stuff as programmers, we often use localhost to describe our own computer. Now, my computer has an IP address. I could probably use that if I want to, but localhost is like a shortcut just to say this computer. Port 3000 is for now an arbitrary number. We just kind of made that up ourselves. That could be 3001, it could be 3002. However, everything after this part is what we call, it's basically path information. So if I have a look at the npm.js website, you'll see that here we have HTTPS, which tells us the protocol. We then have this website, www.npmjs.com. That's the equivalent of localhost 3000. And then we have all this information after here, package/express. That's all the path. That is the information that gets passed to the web server to say, this is what I'm looking for. You know, it's the instruction, it's the request of where I want to find that information. So when I don't put anything after there, it just assumes that the path is this slash here. But if I was to go and say, update this to /hello, suddenly now the Express server knows how to deal with it because I've programmed it to know how to deal with the path /hello. If I was to take this and run it under here and say like, just put the slash there, and I wrote nothing, what I could do is I could then go and stop my code, right? That's something that's a bit new to a lot of you because a lot of you probably aren't used to stopping your code. I could run it again. It starts up my server again with the new code because it's not going to automatically get the new code. And then when I go back to the original URL, it says nothing. And that's because I've told it what to do when you access the slash. So this is kind of an interesting idea because you can start to understand that basically, like, you know, the internet in a sense is a whole bunch of web servers that have names. And when you talk to them, you're essentially sending this like information about, hey, this is the particular thing that I want to tackle you with, which might be a slash or a /hello or a /what's up. npm.js, you've got package express. Bing's got, you know, /search. This website's got en starter hello world, right? Like every single thing has that information after it. And these web servers are configured to deal with it essentially. The reason I've got this other example here is because what I can show you is that we're not always just returning text. Text. Sometimes we return JSON. So in this case here, I actually want to send JSON back when someone tries to access what's up. Now we know about JSON from the lecture, and it sent back some JSON. Now that's a cool thing because, you know, we know JSON's really powerful, and a web server returning it means lots of different applications and stuff can understand it. But that's the crux of the web server. I'd love it at this point if people could ask some questions because I imagine that, you know, like we're going to unpack this more in a bit, but just before we kind of dive back into the theory temporarily, are there any questions about that? Sophie's asked, will linting be covered this lecture or do we have to watch the recording? I know it's not covered this lecture. Yuchao's asked me to do the HTTP servers. That might be a good post for the forum because I just don't know. I can ask Yuchao after though. Someone says, can we start making web-based games after this lecture? That's a good question. So what we're really learning about is not how to make things in the web browser. We're learning about what powers it behind it, you know? So to make web pages is not really what we're talking about here. We're trying to help you build the systems that power those web pages behind the scenes. Is everyone really gone quiet? It's like no more, you're chatty baddies, and then suddenly no questions. Maybe everyone's asleep. Is JSON also a reduced size? I don't fully understand what you mean by that question. Is JSON also a reduced size? So you might have to clarify that with me a little bit if that's okay. Do we need to do WebSockets? No. So if you hear or learn about WebSockets are a bit of a different topic. I'm not going to elaborate extensively on it, but WebSockets are a slightly newer technology that was designed to say, you know what, the actual overhead of setting up an entire request is quite heavy. So, you know, when I type in a URL here and send it and I get a response back, there's a lot of overhead. Like, you know, it's kind of like flying from, you know, Sydney to Wollongong. It's like there's a lot at either end you have to do. But the actual, you know, so if the journey's really short, if what you're doing isn't much, it's kind of like a lot of overhead. WebSockets, you can go learn about them in your own time. It's probably pretty heavy if any of you here in your first year. But they're basically a new type of technology that it doesn't replace HTTP, but is typically used in conjunction with it, where essentially instead of these requests being sent, they actually kind of open like a long-term connection to a server. It's typically used to stream data. So let's imagine that, I think we used some of this in SunSwift back in 2017 as like, we had a solar car, right? And the solar car itself, right, looks like this, but it was sending data to us, right, all the time, like, say 10 times a second. And rather than kind of making these requests to a server 10 times a second, like me hitting enter, like every time I hit enter, I'm like sending a request. WebSockets are basically where you have like a long-term thing open where you can just stream stuff through it, Again, maybe another analogy is like, every time you make an HTTP request, it's like picking up the phone, calling someone, asking a question, they give you an answer, you hang the phone up. So if you start doing that really rapidly, someone's like, why don't we just pick up the phone and keep the phone open? Now, there's downsides to that too, but that's essentially what WebSockets are about. No, we do not learn about them at all. Someone says, maybe he means object value not much and the JSON string not much. I mean, so this is just a JavaScript object here. We talked about that last week. This on the screen is a JSONified version of it. I don't know if I'd say it's a reduced size. It's hard to compare because, this is obviously ASCII characters. So for every byte here, it's going to be like every character is going to be like 1 byte. But like this here is more like a JavaScript object. I wouldn't really know how to tell you what that's. Yeah, I mean, I don't know about a reduced size. That's kind of a hard question to answer. Probably an odd question too. Not as in like you asked a silly question, but like probably, I don't know. I just don't know how to answer it. Love that you're thinking about it though. So that's a little bit on the servers. What are servers used for? Okay, this one's kind of important. In the past, servers were used to serve files to the client's browsers. Okay, what do I mean by that? What I mean by that is this JSON thing you saw here. That didn't used to happen 20 years ago. What used to happen 20 years ago was that people would basically create a page called like About Us. And if I restart my server, because every time I make changes to my code, I just need to restart it. And then someone would send a URL to their website called About Us. And you know what they would do? Is they would go and make the page really pretty. They would go and make some bold text. They would go and add a whole bunch of other HTML, like, color red, font family, Arial. Like this is, I'm just writing some quick HTML. And it would, I got to restart the server. It would do that, right? So this is kind of how web servers existed back in the late 90s, was that they were basically maybe I'm oversimplifying quite a few things here, but they were basically engines that would return web pages to a front end. And that's how they kind of were for a very long time. What changed, again, without unpacking it, is that the internet and web browsers became a lot less about people asking for lots of different pages with lots of different text on it. Like again, UNSW might be a good, oh my God, hello friend. That's cool. I like Stan Grant. Anyway, yeah, so every time I click on a page here or click on this page here, like you can imagine what's basically happening is I'm sending a request to a web server and it's sending me back a whole bunch of stuff that the web browser makes pretty, right? But how a lot of websites have changed is, let's think about YouTube for a second. With YouTube now, what might happen is that you go to a video like this one here, right? And you go and watch a cat experience something. And what you'll have then is you'll have a bunch of stuff on the page here. Like, you can't see it because my head's in the way. Let me just move it over here. Is you have a bunch of stuff here on the side, right? Like this comment button and this share button. And what you'll see is when I click on this comment button, right now my web browser doesn't actually have the information about the comments, I don't think. So when I click on it, what the web browser has to do is it has to kind of quietly go and talk to the server, the web server of YouTube, and get back more information. I click on that. So you see that little loading for a second there? You can always rewind the video. That loading was my web browser talking to YouTube and saying I need more information. But what you'll notice is I didn't actually change the URL that I was calling here. It still says short/KQ whatever else. So what was actually going on there was that my web browser was making a quiet HTTP request with a URL to YouTube, and YouTube would have sent back a whole bunch of information as JSON. I can probably, it's already loaded now, but like I can maybe quickly show you. I don't normally go into this much depth. So bear with me. Just trying to find it. I don't normally do this in Edge either. But watch what happens when I click this button here. I think it made this particular request. Oh, that's big. Yeah. Oof. And this all looks like JSON. Now, I've never looked at this before, but I'm trying to kind of make the point that what it did was it went and asked for a whole bunch of data from YouTube's server, and YouTube actually returned it all in JSON. I think I'm looking at the right one, as far as I can tell. Maybe if I search for a comment in here, like, are you aware? There you go. There's that comment, are you aware here? Are you aware that scandals with that, to fashion? So what happened was the web browser made a request to the server quietly that you didn't see. It had a particular URL. That URL is defined here. It was YouTube/v1/browse. You never saw that because it did it, without kind of, it did it quietly is how I describe it behind the scenes. And they got a whole bunch of JSON back. And that JSON was then used to create the web page. Now, the point of this is mostly to explain to you that how web servers work now a lot more is that the bulk of what they actually do is not necessarily generate like HTML pages for people. It's actually the exchange of information going on behind the scenes. Because when people click things like these replies here, that was another request. This is all JSON getting sent. Typically, they send a request with some JSON, they get back some JSON. If I was logged in and you click like or dislike or something else, subscribe, this is all just communication going on behind the scenes. This is how most web servers act now, is they're essentially just doing stuff quietly and exchanging information with JSON. That's what's going on. So the reason that's important is because whilst I gave you this cute example here with the little bits of HTML, most of what a web server is doing is actually this type of thing here, where it is receiving a request, it is digesting that information, and it is returning some answers, typically in JSON, because it's kind of the universal way of doing things. And maybe that'll be different in 10 years, and that's fine, that's normal, but that's kind of what is used commonly now. So servers often respond with JSON. One cool thing that you'll see about this piece of code is that we can go and change a couple of our lines to make it easier to write the code, because people who write the Express library were like, man, lots of people are using JSON to reply to stuff anyway. So rather than make them do this like response.send JSON.stringify, let's just replace .send with .json. And then they can just send back an object. Like they can just give an object to the JSON command, and it will just send it back normally. And then you replace this .text with .json. And now you have a web server that's just like totally chill with handling JSON end to end. So if I go and restart that now, you'll see that my route what's up will more naturally return the right thing here. Like, /. There's the JSON that I got back. So that's kind of just like a shorthand way of doing things. So we can send JavaScript objects as JSON much easier. Now, how servers receive information is the next interesting thing. So let's say, for instance, that you want to create a URL where you send information to a web server like your age and your name. And what you want it to do is return back to you a piece of JSON that kind of says name and age and gives you a cute little string or two, right? That's all pretty above board. So let's go and grab that one. This one here. I'm going to stop my web server. npm run. Let me clear that. npm run ts node input query. Bam. Running, and I've got this my URL. Now let's pay attention here. What happens when I localhost 3000 my URL? I got this back. You know, it says name, age, name is undefined, age is undefined. Now the reason it says that is because those variables were undefined. But let's take another look at the source code for a second. So when we look at the source code, you'll see that what I'm actually trying to do is capture the name and the age from this particular statement here that says request.query.name. So request is basically this gigantic object that contains all the information pertaining to the request made by the web browser, right? The web browser is the thing on the left. So think of it like this. Web browser on the left, terminal on the right up there. Web browser trying to talk to terminal, it's sent information. Request contains all the information coming from the web browser. Request has a property called query, which is about all the information that comes through the URL. So how we encode information in the URL is pretty simple. That's a normal URL, but I can add information to it like this by saying name equals Hayden and age equals 5. Now, the way that those variables are encoded there is it's a very simple pattern. You simply say key equals value, like that. Name equals Hayden, like this. And then what you do is you join any of them with an ampersand. So if I have many of them, I join them all with an ampersand, like k equals by, whatever else. And then I join all of those together with a question mark to the actual URL. That's the pattern of it. So I join them all with an ampersand, and I join it to the URL with a question mark. I obviously don't need that. And then what happens is when I make that request instead, suddenly you'll notice those variables are there. Because what happened was I captured name via a parameter in the URL and age via a parameter in the URL, and then I simply returned that. If we wanted to change the code, for instance, and say, well, actually, I want to say years until 18, right? Which is just going to be 18 minus age. So now what happens is if I say, I can add a new property here if I want to, called years until 18. And then I say, you're 18 in years until 18 years, right? I can just go write that. I'm making this up on the spot. And when I run that again, did it even run? Oh, it was an error. TypeScript's too smart. I have to turn this into an integer. Because, this is why TypeScript's so good. Prevents bugs. All right. A couple of things in TypeScript are weird, though. Why are you mad? String is primitive, but oh, wait, sorry. I was kind of writing Java. There you go, years until 18. You're 18 in 13 years. So if I change this now to I'm 12, it says you're 18 in 6 years. Age is 12, you're 18 in 6 years. So you can kind of get it. Like that's how you're basically like the web servers exist because you're trying to delegate a problem to them and they give you a response. Sydney Seidel said, that's why YouTube has the URL watch equals whatever. Yes, nailed it, 100%. So when you look at a YouTube video, it has /this up the top. It's not quite in the format I just described, but URLs are basically just inputs. That's all they are. And I always talk about this. It's such an interesting idea because if you think about it, it's basically like URLs exist to link share, to bookmark as a general rule. They're a way where like you can pass on the specific information about the specific thing you're looking at. Because obviously someone could go to YouTube/shorts, right? But they don't want to go to YouTube/shorts. They want to look at the video you're looking at. So you give them a bit more information in the URL so that when they bookmark it, they can come back to it, or when they send it to someone else, they can access it. Now, you kind of probably figured that out already, but what's actually happening there is that's just information that the server is taking in that tells you what it's going to generate dynamically. So, I wonder what the link is to. Yeah. Would URL being the input be a security issue? Yes, 100%. We'll talk about that soon, but there are other ways to send information that is more secure than the URL, absolutely. There's certain things you'd never send over the URL, for instance. Okay, so we talked about one way to receive information. The other way to receive information is to do what YouTube does here. So take YouTube in this case, right? It's got this format short/something. Well, you know what would be really nice if we could have that format too. Sorry, I'm just jumping around a bit. Input params. So I have a look at this code here. Now I'm actually going to go do my own. I'm going to go and modify this a bit because we were looking at YouTube. YouTube is going to have this format called /short/something. And I might replace this and call this video ID. Now, if I put a colon before a piece of text here, it basically turns that into a variable such that I can capture it like this. So before we had request.query, which was how we captured that specific piece of information we saw before. But this time we've got params. Params describes anything in the URL path that is potentially variable, like what YouTube does with shorts. Now, in this case, nothing's going to be particularly interesting. I'm just simply going to show you that if I start up the web server, that we are able to, sorry, what was the URL? So let's say I want to do my own little YouTube thing, localhost 3000 /short/that. Cool, so I've captured that. Now, obviously, all I'm doing is returning that back to the user, which isn't super useful, right? However, that's useful if I'm then, for instance, from there going to make a database query or something and fetch that particular video and give it back to the user. So you can kind of see how, like, you know, what we're doing with web servers is capturing information, doing some stuff and returning things to it. That's how YouTube would work in a nutshell, right? It's just capturing that over the URL. You know, it might not be written in Express or Node.js, but the principles are all kind of the same. So yeah, those lines of code are unique there. Now, what we've just shown you is how to send and receive information via app.get. There are some other things out there that we can use. And in this case, I'll show you one is called app.post. App.post is actually where we can send information not through the URL. So I've got another example here, app.post, where we're actually going to send this URL to /hello, and we're going to capture information a different way. However, the problem with this is that we can't use the web browser to do this. And I'll show you what I mean. If I go and run this code, post example, right? And you think, oh, I'll just go to the web browser here and I'll go and access /hello. It's like I cannot find it. And the reason for this is because all web browser requests that you type into the URL is making a very specific type of HTTP request, which is called a GET request. Now, if you want to make other types of HTTP requests, you either need to write code to do it typically, or use a different program. Web browsers are not really just good out of the box to do it. So this is where we need to talk about API clients. Now, we have one already installed for you on the CSE machine. I was going to use that today, but I was having trouble with VLab. Let me just see. One sec. Let me just... 2 seconds. Just going to try and install this program. Normally I do this lecture on VLab, but I was having issues last minute. So I'm just downloading something really quick. But this tool I'm going to show you, you can use it on VLab just by running this command 1531 arc. There's lots of programs like this. The programs that we're looking at are what's called API clients. API clients are essentially tools that you can use to talk to web servers instead of a web browser. So they're great tools that developers would use to essentially emulate things that a web browser might otherwise do. Oh my God. One sec. So I've got this tool up here, right? Let me just click next. And this is the tool. It's actually really kind of, I wouldn't say it's super similar to a web browser, but like for instance, you know, let's go run a previous piece of code we had, like the query one. If you remember, we called a particular URL like here. And I can do the same thing with these tools where if I go and put this over here, I can say, yeah, I'm going to go put that URL there. And then I hit send. And that's weird. Did I change the URL name or something? My URL. The URL request? Really? Huh. Sorry, guys. I'm not 100% sure what is going on here. I normally do this on VLab. Very odd. So it's basically, this is the equivalent here of saying like the server's not running. And that's interesting because I guess if we try it in the web browser, oh, wait, let me try localhost again. Okay, so the web browser seems to be running now. But that's weird because if I take this right and I put it straight into here, it's like it can't be found. Let me just check if it's some permission issue. Not too sure. Well, just while I'm trying to figure this out, let me unpack a few extra things for you, right? So firstly, the port is a pretty arbitrary number. It generally needs to be a number that's like about 3000, but it can be a whole bunch of different things. If I change it to 3001, all that really does is change the actual port that you're accessing a web page on, right? Like that. Well, or more specifically like this. Okay. That can be any number. On any given computer, there can only be one port, one program running publicly on a certain port at any given time. This is really important to note, particularly because of how VLab works. So if you're at home, there's pretty much never, when I say you're at home, if you're on your own computer, like I am today, you running code on port 3000, 3001, 3002, it's all kind of going to be the same. It's all going to work fine. However, it's once you start getting on the shared systems like VLab where things get a bit tricky. If you're on a lab machine, that should also be okay, I think, because lab machines run standalone. But when you're on VLab, when you like Tiger VNC or SSH in, you're actually on like a shared machine with a bunch of other people. Now, there's actually many VLab servers. There's like 12 or 20 of them or something like that. And they're all very different. So what that means is, let's imagine for a second, there's 1,000 people using VLab at the same time and there's 20 servers. There's about 50 of you who are going to be using the same underlying computer. So if any two of those people try and run their little web server example on port 3000 at the same time, they will get an error. And I'll show you, right? So it's like, I can show you what happens. It'll look like this. You're running your code on port 3000. Sorry. All kind of fine and dandy. And then someone else comes along. You open a new terminal. Someone else comes along and they try and run it on the same thing, npm run ts node input query.ts, and suddenly it's like that error, address already in use, address is already in use in 3000. So if you were that person, you would come along and change it to say 3001, run it again, and it will run fine. You might be asking, I'm really confused because when we're developing this stuff, we're using all this localhost 3000, but when we go to a website like YouTube, it just says youtube.com. So just a quick thing to unpack here. It's really simple. Every computer has an IP address, right? Might be like something like this. What you then have is a whole bunch of names like youtube.com, and that points to an IP address. So typically when you type in youtube.com, it'll point to something like that. It's a big oversimplification. Also, when you do that, there's two ports that are just implicitly used on the internet for certain things, and they are port 80 and 443. Port 80 is the HTTP port, and port 443 is the HTTPS port. Now, the HTTPS port 443 is there by default when you do HTTPS. So for instance here, if I add, I think it's 443 there, you'll see that it just kind of disappeared. And that's because it's like the browser's like, I already know it's 443. You don't need to tell me that. Like that's just the port that's used on the internet. The different port numbers like 3000 are only really used when we're developing stuff locally. So for instance, developers at Google, when they're working on a YouTube server or something, they're probably running some localhost 3010 or whatever else. But when it's actually on the internet, you don't need the port there because the port is still there. It's just a specific port that everyone's agreed on is the port to do this stuff on. So people are asking too, is this content useful for iteration 1? No, not at all. Everything from this week is for iteration 2 onwards. So don't worry about that. In fact, a lot of stuff from last week is also iteration 2 onwards. Now, I need to show you this thing. However, I'm not sure why this isn't working for me. So let's take a short 3-4 minute break, just so everyone who's watching live can stretch your legs. And then we're going to continue, and I'm going to be doing the rest of this in VLab, just so I can show you some extra stuff as well. So chill out for a few minutes. Hi everybody. Hope you had a good break. I was hungry, but I didn't have any time to make food, obviously. So I just ate like a tablespoon of peanut butter. You know, I never used to like peanut butter. I didn't think I'd really had it. I was like, I don't think I like it. And then I ate it one day, and I was like, oh, really been missing out. I wish it wasn't so unhealthy. It's just so tasty. Anyway, back to it. Let me hit record. Okay, so we're now on VLab, right? Now, the purpose of getting on VLab is to get you some exposure of what the environment's like in VLab and also show off one of the tools in CSE. So what I've got here. I'm so sorry. The recording crashed again. Third time's a charm. So what we were talking about before was that we know API clients need to talk to servers. However, one sec. Sorry. Yeah, there are unpack. 2 seconds. Okay. So what we were talking about was we know that there's some types of routes that we simply cannot use web browsers for. So for instance, here we have our post example. If I run that one, post example, sorry, need to npm install. So now I'm on VLab. I'm doing things a little bit differently for the second half of this lecture because a bunch of students still use VLab. So I think it's important for them to actually kind of see that the environment that they're working in. It's really not much different. But what you'll also see in the meantime, whilst that's running, is I did run a command called 1531 ARC. That starts a program that we've installed on the CSE machine. You can go and install that yourself on your own computer if you want to. I have it up here already. We'll talk about that one in a moment. So just after it npm installs, I'm going to run it. And what I'm going to show you is that this server here with the /hello, if I try and access it, localhost 3000 /hello, we're going to run into some problems. npm run ts node post example. There we go. Cannot get hello. And again, this is because web browsers are all based on get here. If I change this to get, this will kind of work, right? If I run this again, you'll see it'll give me a bit of an error. Well, maybe not an error, but it won't work exactly. Now it just says name is undefined, right? So it's this get part that matters. And then it's like, what the hell is this post thing and what the hell is this body thing? It's a different way of communicating over HTTP. Web browsers can't do it though. You know who can do it though? API clients. API clients, you have lots of different methods of talking to web servers. Whereas web browsers are just the get one. But I have a post one here where I'm going to actually say, well, 3000, /hello. And then I'm going to hit send on that one. And it worked. I got back, it said my name is undefined here. I don't know if I can zoom in. However, we showed previously when we do a GET request that we can send information via the query with the question mark and the ampersands. We can send it via params, which is through the URL. Whereas with post request, there's a different way we send it, which is through the body here. And in this case, the body I'm putting in as name is Hayden, which I think is what the code wants. Request. Oh, sorry, that's a typo. .body.name, like that. So instead of request.query or request.params, I have request.body. And when I go and restart my server there, you'll see that this works now. So if I change this to, I don't know if this works. Angry. It's probably not going to go through to VLab. No, I don't think so. I don't know why I never learn. If I change that to something else and then I call that, I get a different response. So now we've kind of learned that, you can do query and params, or you can do a whole different thing that isn't app.get. It's actually app.post, where you send things a different way. But this all starts to get really confusing now, right? Like we've seen the API client, we've talked to the server, we know web browsers make GET requests. And what this comes back to is an important topic called HTTP CRUD methods. GET and POST aren't the only types of requests that we can send to web servers. There are more than 4, but there are 4 key ones. They are put and delete. And what that makes up is 4 key methods, which is post, put, get, and delete. The reason we call them CRUD methods is because they function as the 4 fundamental kind of request types, which is to create something, to read something, to update something, and to delete something. Now, it's important to note that these 4 different types aren't like fundamentally like different. And what I mean by that's like the web server, they're not like crazy different. A lot of the time, the main difference in them is just the name. So they're mostly a signal to developers and people writing web servers, right? That this is what the particular operation's about. So when you make a GET request, what you're really saying is like, hey, I want to read some information. Whereas when you make a POST request, you're meant to be kind of creating something new. When you make a PUT request, you're meant to be updating something. You can not do that. You can ignore those rules and everything will work fine. But that's like kind of the purpose of those different types of methods. Now, all of these 4 methods, we can easily respond with JSON. All of these 4 methods will have the request.params approach work for them. That's the one we saw in YouTube, youtube.com/short/whatever. However, whether they work with request.query or request.body is a little bit different. Typically for request.query, that only works with get and delete requests, and for request.body, that only works with post and put requests. So what I mean by that is in this case, we've used a body, but if we were making a get request, we send stuff over the URL like this. But both get and post requests do take in the param stuff, which is the YouTube short thing. If you kind of forget about that, you can always just reference the table. We do have the kind of information there. There are more HTTP methods than just those ones that I mentioned. They're all kind of here. This is another Byte Go one. They do great educational animations. Get request, post, put request, post request, delete request. We've also got patch, head, connect, options, trace. They're all a little bit more complicated. We don't really talk about them. A lot of stuff you'll see will really only focus on get, post, put, and delete. So don't need to worry much more about that. Now, what everything we've been learning about here feeds into is the concept of an API, because we've essentially been, over the last hour, very gradually getting you comfortable with the idea of becoming an API developer. And you've been seeing the building blocks of building an API, but it still begs the question, what the hell is an API? An API stands for Application Programming Interface, and it refers to what a particular piece of software exposes on the outside of it, right? Think of a piece of software like a black box, for other people to interact with it, Functions are basically APIs if you think about it. Like a function is some name that does some stuff that you don't know how it works. And it tells you, hey, if you pass in these parameters to me, I will return you something else. We use the term API in web a lot. In fact, often when people these days say I have an API, they just mean I have a web-based API. I have an API that runs on like HTTP requests that take in get, post, put, delete. That you can access via URLs, that's the majority of what people mean when they talk about APIs these days. And it's just a black box of a web server, that's really it. And I kind of alluded to this earlier on, and I think I want to really reiterate this point now. This is more just theoretical background understanding. But when you go to youtube.com/short/ABCDEFG, what happens is your web browser sends a request to a server saying, give me an entire website, and it loads back the whole page. Well, once that's loaded, the rest of the requests that go on, all those comments and likes and subscribe, they're typically just exchanging JSON at this point, and it's basically YouTube acting like its own API to itself, where the server's this black box and your web browser, the web page you're loading is talking to the YouTube API saying, yep, I want to get a comment. I want to, get the sub comments of the comments. They're all get requests. And then it's like, I want to like a comment. That's a post request. And then it's like, I want to edit my comment. That's a put request. And I want to delete my comment. That's a delete request, all just kind of JSON packets being exchanged back and forth. That's what an API is. You've kind of gotten a sense of it. And the clients of these APIs are either web browsers or, these API clients. That's why we call them API clients, because they're basically tools that work on the client side that help us talk to a web server's API and interact with it. That's what they are. So when it comes to the post, I said before that most APIs these days are what I talk about. That particular type of API is known as a RESTful API. And a RESTful API is an API that uses HTTP requests to get, put, post, and delete data. You know, there are other APIs. You'll see like there are other web-based APIs, like there's GraphQL APIs. GraphQL APIs are just a different way of communicating over HTTP. There'd be APIs out there that aren't anything to do with HTTP as well, but most APIs these days will be a RESTful API. Maybe that'll change in future. It will take a long time because it's just such a vast majority of stuff. Now, one thing we haven't talked about is you can make a GET request over HTTP via your web browser. You can also make any type of HTTP request, put, post, delete, or GET via an API client, which we didn't do a ton of, or you can make an API request via code. Now, the code part's really cool. Before we get into the code part, I probably do want to kind of quickly show you another couple of examples of using the API client. Let's go and run our previous code, which was our input query one, right? So if we go back to our input query code, you'll remember that it was /myURL. It was a GET request. It took in name and age. Okay, so I go GET request, my/URL, name equals Hayden, and age equals 5. I should get a result. Header's not valid. It's fine. And I get that result. Okay, so that's pretty cool. If I run a different example, which was our params one, input params, and I go here, you'll see that this was the one where we were like my/URL. We kind of changed this to be the YouTube Shorts one. But for instance, I can change this one, my/URL/Hayden. The way this information is captured is via the path itself, or the params, not via the query, which is the information after the path. And then we already did the post one. So lots of different methods here. Now, the only reason I've showed you GET and post is because put and post are pretty much identical except for name, and GET and delete are pretty much identical except for name as well. So if you know how to use GET, you know how to use delete. If you know how to use post, then you know how to use put. So that's why we don't need to go into detail on every single for. But now we're going to talk about requests made by code. This is really fun. So there are libraries out there that help you make HTTP requests via code, right? There are many good libraries for it. But a lot of the good libraries, they require a lot more understanding about JavaScript. That when the course was rewritten for JavaScript, the determination was made that it was too complicated, basically. Like it would just be more confusion than it's worth. So what we have instead is a kind of a really bare bones library that's not really used at scale or anything like that. You don't really need to worry about all this context I mentioned. But the short story is it lets you make HTTP requests via code. So if I bring up, and I might jump back to my own computer here for a second. Let me just get rid of some stuff. So I've got this piece of code called request.ts. Here it is here. And it's going to try and talk to a server on localhost 3001 with path/Apple. Okay. Now, some things to note about this. It's a GET request. Makes sense. That's the URL. Makes sense. I might do this to start. Name equals Hayden. Sounds good, right? And I'm going to load up. Which one had name? Which one has Apple in it? Apple. CRUD. Okay, that's the one. So I've got this particular HTTP server here called CRUD, which has a GET request for Apple and a POST request for Orange. Pretty simple server. I'm going to go get the JSON version. No, I want to just change this to JSON really quick. Give me a sec. Request.body. I'm just going to clean up this code so it's a little bit smaller. This looks good, pretty simple. Get Apple takes in something via the query, returns it, and it's going to run on port 3001 just to show you that we can run things on different ports. So what happens is here, I'm going to call localhost 3001/Apple. Yep. It's a GET request. Yep. And it expects a query variable called name. Cool. That makes sense. So name equals Hayden there. So in one of my terminals, I'm going to go and say npm run tsnode crud.ts. That's the web server running, right? And then in another terminal, which I have to bring up over here, what I'm going to do is, in 4.2, same folder, I'm going to do npm run tsnode on request.ts. Now remember, request.ts is this one here that's making the request. It's a very simple file. I hit enter, and you'll see what it does is it fails. Did someone not install that? Ah, yeah, okay. They had the wrong version there. Ugh. I might be using an old, I think my terminal might have been using an old version of Node. There we go. I think it was using Node version 12 before. So now I'm going to try it again, run requests, and there we go. There's the output. Now the request library does have, like, it doesn't do the best on return because, like, when you get the response from the request, we still need to get the body of the response. We still need to cast it to a string. We still need to JSON parse it. But it's really easy to write a helper function for that, right? Like I can just write get response function, get response. It takes in my response and it simply, you know, returns that. It's really easy. So then I can just simply in the future say, you know, get response like that if I want to, you know, and you could do this obviously a bunch of better ways in terms of, you know, more concise helper functions. But the point is, if I pass in a different thing here, like hello, I'm going to get a different response. We're basically doing the same thing we did in the web browser or the API client, where we simply make a request and get a reply, which is great, super helpful. And the server's running on localhost 3001. If I want to go do another thing where I go make a post request, right? With the post request, well, what is it? It's to /orange, and I need to pass in a body. So, you know, /orange. And since it's a post request, nothing in the URL. However, there's another parameter. The third parameter of the request library takes in a series of options. And these options, what they give us is they give us essentially things we can add like a body here. So I could say, well, my body is going to be name is Hayden. So I think that takes in a name as well. Yep, takes in a name as well. And I do have to restart my server now. Pay attention to these two terminals because I've modified, actually I don't need to restart the server. Ignore me. I didn't need to do that at all. So I run that one and I'll see I get an error here and it's like, okay, this isn't good. What's going wrong here? It's confused because it's expecting the body, I think, to be a string. So I'm probably gonna have to JSON stringify that there. I think. Nope. Oh, was that just a double declaration? My bad. I think it works without the JSON thing, but maybe no, it does need it. Always get confused. There you go. So it does need to be JSON stringified. So the body argument of the request library is expecting you to give it a string, right? It's like, hey, I'm going to send a body back to the person who's calling me, but I'm going to send a string to the person I'm sending the request to, right? To the web server. Please give me a string. Now, again, you could obviously abstract this pretty well into, you know, a little helper function. The other thing you might have seen at the start, if you have a keen eye, is that the request library actually has a helpful way to do query stuff too, which is you don't have to write it like that. You can actually do QS there, which means query string, and you can actually give it the same parameters. And what it will do is it will go and put it in the URL for you. That should work for us here. That's particularly useful because it's really difficult to kind of jam variables in that URL. Someone asked, why do we still get hello instead of Hayden? It's a great question, actually. Oh, probably because I didn't restart the server. I probably changed the text or something. What was the server returning? It's a good question. I'm not too sure. Just double check. Maybe it was fine, I'm not sure. Doesn't really matter. So now we've shown that we can write code that will go and call the web server, which is great. Cool. Any questions about that? Just have a quick pause for questions if there's any. Why are we getting apples instead of oranges? That's a funny question. Yeah, I'm not too sure on that one. It's just what I wrote in the example, really. Okay, let's move on a little bit. So that's the request library, pretty cool. How we're going to wrap all of this off today is learning about jest and testing. What's really cool about this topic is that we're just simply tying together two things that you've kind of learned at this point, which is jest and the request library. And we're essentially going to try and tie them together. So I've got this new file here called request.test.ts. Now what I've done is I've very conveniently gone and abstracted away the function to make GET requests into a nice little helper. This is a good idea. I recommend it. It's why we give you the code. I have a function called GET, takes in a path or a route, and then it takes in a query string, which is the object that we want to inject in the URL. And it hard codes in the GET, hard codes in the localhost 3001. It does all the JSON return stuff. So now, if you think about my tests here, right, if I comment this out for a second, this is all just jest, right? You've seen jest already. You're writing jest as part of iteration 1. And as part of iteration 1, you will be already having done, or hopefully having already done, written some code that will like call a particular library, like a library in one of your auth functions. However, this time in iteration 2, instead of calling an auth function library, you're going to call a particular URL. You'll learn about this more next week when you get the spec. And what I do there is I say, well, I'm going to get /apple and I'm going to give it name Hayden. And I expect what I get back, I expect the message in the object to be, hi Hayden, thanks for sending apple. It's pretty easy, right? Like I'm literally just taking the code from requests and putting it in a test file. So similarly now when I go to run that, all I need to do is go npm run ts node, what's it called? Request.test.ts. Sorry, I need to use jest, npm run jest, request.test.ts, right? That is using the wrong library too. Strange. That should work now. Oh. What's happening here? Sorry, that was meant to be a dramatic, like, one of my tests is failing. Does anyone know why it's not working? I feel like I've written my test correctly. Should be a pretty low baller question. Hey, YouTube friends, what do you think it is? Just playing with the camera. Server isn't on. Perfect. So this is one thing that's a little bit tricky because in iteration 1, you're obviously just running a test and there's no server that really needs to be on because your test just directly talks to the JavaScript. Whereas with iteration 2 and this different stuff, it's a little bit of a trickier mindset to be in because even though your server and your tests are written in JavaScript, it doesn't really matter because they're communicating over a network. So you could write your server in Java and your tests in JavaScript and vice versa. It doesn't really matter. So your server actually needs to be running. And the server was crud.ts. Sorry, what? npm run ts node. I swear I wrote crud.ts. Anyway. There it is. And now when I run my tests, it should pass it. And that's because it's talked to the server. And just so you can a little more intimately understand that dynamic, I'm just going to put a console log in my server saying calling /apple. And then I'm going to do the same thing down here that says calling /orange. right? So, for instance, there it's like, okay, npm run jest, that all works now. And you'll notice that when I'm calling it, it says on the left calling /apple. So that's the server, a whole separate program just responding to when something hits it, like with a request. And the thing I have on the right here is the actual kind of test running each time. Now, obviously, I commented out a bunch of stuff in the test, so I can go and uncomment that again. Here we go. Like that. Pretty chill. Cool. And then I can go run my test again. I don't need to restart the server because the server hasn't changed. And you see in that case, it is now calling /apple/orange. Someone has asked an exceptional question. Thank you, Carl, which is, how do we get this working with the continuous integration? So, Yuchao talks about continuous integration. And obviously you kind of get that you can just write npm run jest and it will go and find all the jest files, right? But then it's like, well, in iteration 2, we've kind of got like this server that needs to run. So it's like, how do we start the server and stuff like that? It's actually not a trivial problem. The good news is that when it comes to iteration 2, we actually just update your gitlab.ci.yaml file for you. So you don't even need to worry about it. We kind of give you the commands that go and handle that all for you. But yes, it is handled such that your server gets spooled up before the tests run. I do want to really reiterate though, that the difference again is that, iteration 1, your jest are just directly importing stuff. It's like one big JavaScript file. So you got jest JavaScript, it just imports JavaScript straight into it and tests it all in-house. This one, the testing jest thing here, doesn't really know the other code even exists, right? Like it doesn't know that this crud.ts exists. It's not importing it. The crud.ts is running over here totally separately, and they are literally communicating via the network card on your computer, via a little network with a URL and an address and a port and stuff like that. And that abstraction, to understand that's really important to get your head across. Okay, so in iteration 2, you're going to need to implement an HTTP server. However, many of the routes that exist in iteration 2 are just wrappers of your iteration 1 functions. Yeah, so this is something that you'll kind of see more of, I guess, next week once iteration 2 comes out. So we don't really need to talk about it now. It's more just like a heads up that, all the work you do in iteration 1 is really easy to expand into iteration 2 because you can just simply take the logic that exists and you can put like the express stuff around it. If that doesn't make too much sense now, don't worry, because we will cover it next week in detail. So I wouldn't worry too much. Okay, before I keep moving on, are there any other questions that people have? Because we're getting kind of towards the last bits of this, and I just want to make sure that people aren't kind of lingering thoughts and questions. Okay. Well, next one, returning errors. This one's pretty important, actually. In iteration 1 and prior, we kind of tell you, if you want to return an error, you simply return an object that says error in it. Now, thankfully for iteration 2, you can actually still do that. However, what we do need to tackle a little bit more is HTTP status codes. So when it comes to HTTP, every request that you send comes back with a response. And typically that response contains some information, like the YouTube comments we saw. However, it also has attached a particular status code. A status code, there's a long list of them. There are many of them. Every little blue hyperlink you see here is a status code. They're all broken up into different areas. Status codes with 100 to 199 are informational. Anything that has a 2 in front of it is successful, like the request you made was successful. Anything with a 3 in front of it is like we're going to redirect you to another resource. Anything with a 4 is the person who made the request, i.e. the web browser who sent the request to the server, did something wrong. And anything that's a 5 in front of it says that the server did something wrong. So whenever you see a thing that says, like, think about it, like error 404, path not found. You've all probably seen that in your life. That's saying, hey, I'm a web server. You asked me for this URL and it doesn't exist. I think you made a mistake. That's why it's a 4-1, because it's like the client made a problem. But if you see something that says like server error 500, that's like the server saying, this isn't your fault. I've just like totally cacked it. There are many error codes that we need to that exist, but we only need to worry about a few of them. Someone's asked about 418. I'm a teapot. The server refuses to attempt to brew the coffee with a teapot. April Fool's joke in 1998. There you go. I didn't even know about that. It's pretty funny. Engineers, I guess, have a sense of humor. There's only 4 we're really going to be concerned with. Well, maybe 5, but 500. You don't ever need to worry about this in the sense that you will not be creating these. You might see them appear sometime. I'll show you what I mean. Let's go and have a look at, let me just double check the lecture code, 2 seconds. No, okay, so let's unpack that a little bit. I've got this code here, request.ts. What I didn't show you is that when you get the response, you can also print out, I think, is it status? I'll just try it out. It's one of the two. Let me see. It's either status or status code. Oh, it prints in the test, my bad. Status. Where is it? Can normally print hello. If you if you print stuff in your test, it obviously comes out in the jest output. Oh, sorry, that's not the test file. My bad. Here. Yeah, I'll just put in response. Response.status code. I'm going to try status code. Yeah, 200. So 200 is like successful. Great. If there's an error, you'll see a different one. Let me go introduce an error into the CRUD thing. I'm just going to randomly throw an error. You don't need to worry about what this piece of code is. But it is me basically causing a crash on the server. So I'll restart that and we'll make another request. And you'll see the response this time will be 200. Why is that? Very strange. Throw new error. Probably missing that line. We learn about what I just do in like week 5 or 6. So don't worry about it too much now. Yeah, you'll see there's an error there. And if I scroll up, it says 500. That means the server's like, I'm sorry, I screwed up. That's the server having a little, crash. All the other errors though are user created a problem. So when I mention these 5, you don't really need to worry about 200 or 500 because you're just trying to not have your server throw back 500 when you don't want it to, right? Like you never want to see a 500 because if you do, your server builder's in this course. You screwed up. 200 is great. You'll never have to throw it because it's just a default response. When you do response.send or response.json, it's just sending 200 because it's just assuming everything's going to be fine. However, sometimes you need to send one of these 3 back. Now, the way you send it back is pretty simple. Let's imagine that I'm designing my particular route here, my CRUD route. And if someone enters an empty string for the name, I want to return an error. You should be familiar with this general idea. If name is empty, then what I'm going to do is I'm going to, instead of returning a nice friendly message, I'm going to return error. And I'm going to say something like, the name can't be empty. Okay, that makes sense, right? And if I went to my request.test file and we made another test, so I'm going to say like test if it fails on empty return, then I might send an empty string and I expect the response to be, well, actually, yeah, I expect the, error to be something like this. However, if I just restart that server, I don't think I needed to restart that. Did I? I did. If I go and run this now, you'll still see that, well, the test passed, right? Because it did what it was told, but you'll see that it was returning a status code of 200 in both cases. Now that's not really good because, you know, and I probably should, I'll somehow return, let me try this out, body and status code. So now I'm having my helper function return me a couple of things. So when I capture this out here, I need to capture it like this. Now, what I'm saying here is that my thing has errored, but it's still returning a status code of 200. So what I would also expect is that the status code should be, if it fails, 400 because bad input was put in. But if good input was put in, it should have a status code of 200. And I can go and put another status code here and say, you know what, I expect this one to be 200 too, because that one should also succeed. So now when I rerun my tests, I should actually fail a test because, it's complaining, one sec. Body. It should fail because it's like, what is it? 3 failed. Oh, received undefined. So what's happened here is I've probably, when I've made the request, captured status code in a weird way, and I have, because that doesn't make sense. I should capture it like this. This is just me not writing JavaScript properly. There's not really anything else that should go on here. Status code was not a property of body. It was just another variable next to it, right? Like this. That was just me writing bad code. And you'll see, yep, 2 failed, 1 passed. And in both of these cases, it says, yep, received 200 in the case where it fails on an empty return, but it should have been 400. That's not good. And then this last case here, it says, well, you know, for test orange, which is this one, it says it expected 200, but status code returned 400. And it's like, okay, that's probably just because I wrote the code weird. So what you'll notice here in this code, just to be clear, and the reason that didn't work is because I've abstracted away the get function really nicely, but I didn't do that with the post function. So if we want to do a post function, we would just have to make our own little function, change it, and say that we're actually passing in a body like this. I could go and clean up how complex this piece of code is here, because I could do what I've done here, and instead of saying request, I could just say post. I could just give it this URL here, /orange, and then I could just give it the object, this one, you know, and then I could do what I've done in the previous cases, and I could simply capture the response here, like this. There you go, right? So that's just me abstracting it away. That was just some code refactoring, nothing too crazy. I restart this, I open up my test, gonna see how it goes, run it again. I should still get 1 fail. I have a bunch of syntax errors in my code, if I can spot them quickly. There's one. Maybe that was it. I don't like reading syntax errors. There we go. So now only 1's failed. And that's the one we thought would fail because it's the one where if something goes wrong with the CRUD file, right, we aren't returning a status code. So remember, all responses will default to 200 status code. However, if there's an error, I typically have to say, hey, by the way, there's a status of 400. I can just kind of shove it in there like this. I can run that again, and it should pass, should nearly pass everything now. What is it? This one's getting mad at server responded with status code 400 body. The name can't be empty. Use response.body instead of get body to not have an error thrown. Sure. Let's look at that. Let's try that out. Let's do what it says. Haven't seen that before. Let's give it a try. Yep, so this one's still upset. Option value must be a string. Well, we've clearly screwed something else up here. What is it exactly complaining about? It is saying request post. Looks kind of fine. Option value must be a string. Is this the thing where we need to, I think it's probably just what we learned earlier, I imagine. We need to stringify it. Might have missed that when we were deleting stuff. It does say it must be a string, so maybe it's that. Yeah, there we go. So that's kind of working now. Now we're actually getting a response, but the problem is the undefined part's not coming through. So it's like, no, that's not too good. Wonder why that is. But if we take a quick pause there and we have a look at the left, we're getting this thing here that says cannot send headers after they're sent to the client. It's like, gosh, what is all of that? So what that is, just so you're all educated on it, is that when you write code like this, when you do response.status, the Express server can only really send back one JSON or one send. Anytime it tries to send more stuff after it's sent something, you'll get that error. There's two ways around that. One is I could put this in an else statement to make sure that only one is ever executed like that. The other way I could do it is that when I throw an error, I could simply put in a early return like this. So if I put in an early return like that, we should get around that problem. So now we won't get that error. If I restart my server, run my code again, there we go. Everyone's kind of happy now, except we're getting the wrong thing. It's saying that we received nothing back. So now we go and say like, well, let's debug our server now. Well, in this case, we're sending back name. And it's like, well, let's make sure we're actually capturing it from the body. So I'll console log request.body just to see what's there, just to make sure that's all okay. Restart my server, runs on the port. I run that again. I'll see that we're printing out empty. So it's like, oh, so the body isn't actually coming from the test. So that helps us look deeper. So then we say, well, when I pass this in, it's not actually making its way here for some reason, which isn't really good. It's actually probably a good example of like where I think, I don't really know off the top of my head the rules around LLMs and stuff in the course. I've been trying to talk to more and more students about it. But what I usually say is like where they are actually sometimes really useful is for a really specific situation like this. So what I might do in this case, I'll just kind of show you this. I've got to make sure there's nothing I've done that's like, because I use this for work. Seems fine. Anyway, so let's say I've got my little LLM up here and I'll basically paste that in and I'll just say my test just /orange isn't receiving the body that I'm sending it. And I'm not sure why. I think LLMs can be really useful for like these really specific narrow problems where you've really nailed in on the problem. And it might be something that you might go to a tutor, because we always talk about when it comes to tutors, and I know what the problem is here. And they've written, add this line here, is like your job as a programmer should be to isolate, my code isn't working. This is where it's not working. This is what I expected to do. This is where it's not doing it, right? So if you went to a tutor and you were like, I'm making a request. I know it's in there because I've console logged it, but it's just not getting to the server. That's what they'd normally help you with. Here, I got the answer straight away, which is that I'm missing some headers and there's some explanation about it, right? If I was trying to use LLMs to basically write entire chunks of code for me at this stage of my learning, like you are, that would be where I'd be doing myself a disservice. But that was excellent. I just saved myself a significant amount of time. I got a clear answer. And it is that when you're sending JSON over HTTP like that, you need to include something else so that the person receiving it knows you're sending JSON. Otherwise, it will just ignore it. So now that I've added that in, I can run this again. I run this. I should pass on my test now. Sweet. That's all good. And I can see the console logs coming through, and I can get rid of that console log as well in my CRUD. And we're all happy. But the main point of that, obviously we went on a bit of a journey there and touched on stuff, is when you throw errors, you can add status codes too. But generally, you're only going to be adding status codes that start with a 4, because a 200 is the default one. You don't have to write it. We didn't have to write it down here. 500s, you'd never want to have happen ever. So if they kind of happen, it's not because you coded in 500. It's typically because like something's crashed. So it's all the 400s that we write in, and you will get exposed to that with iteration 2 as well. A few other quick tidbits about Express. First one is that we often go and put versioning in our URLs. This is not something that we talk about in exceptional detail. However, what you will see is that in the real world, what happens is people go and create an API. Let me see if I can find one. I usually use the Intercom API. No, Kenny's a good one. We use a tool, it's a free tool we use to build our service with. at work, like my private company. And they basically have an API that looks like this. I don't know. I want to find one that I always forget which one to look at. There's lots of APIs, different products. They all have APIs. Messenger. REST API reference. Introduction. Conversations. Yeah. It's like the same. They look the same. You know what I mean? Like, have a look at that. Like, sure, it's black and one's white, but they kind of look the same. You know, it's like, here's an example. So what these things are basically saying is like, hey, where's an actual request? List posts. So what they say is, hey, if you want to list all the posts, imagine it's like a forum. Here's the URL to call on the World Wide Web. Here's the HTTP method to use. Here's all the things you can give it. And here is what we will give back to you. That's what the APIs say. But the point is, what you'll notice in this API here is this thing here, this V1. The reason this will be in a lot of APIs, and the reason we include it in your project too, is to help kind of emphasize the fact that typically what happens with APIs is that there'll be like a version you have to implement like this one, V1 post list. And then over time, you might go and develop a better system. However, just like we talked about with NPM, like Express version 4 to Express version 5, because the version of that changes so much, it's different, and people can't just change the name. You know, they can't just change V1 to V2 because it's probably a different set of arguments. It's probably a different response. It would break your application. So what they do is they have their V1 API over here, or routes on their, routes on their API that are version 1, and then they go and create a second version, and they run those two things in parallel. And then they basically say to everyone who's on V1, hey, we're going to be getting rid of that in about a year, on this date. So you need to spend the development, engineering, software time to go and change it to the new API and launch it, because we're going to turn it off at some point. This is really, really common with software systems. If you see the V's in the URLs, that's why they're there. You don't have to think very much about that in this course, frankly, but it is still important. One other little random note that we have to throw in is that with the params in the URL, you got to be really careful. If you have a URL that's like /game and then you have one that's like /game / some other variable, you need to make sure that you order them a certain way. If you do this one, for instance, this will give you problems because the way that Express works is it reads through the URLs in order. So if you have one, for instance, here that's like /apple and then another one that's /apple, but they're different because this one here takes in like a random variable, then if you just kind of call /apple, what will happen is that this one will get captured first because it considers this URL to match this string here. It's just that variable is like empty. That's just a random small thing. 99% of you statistically won't run into that problem, but one group will, so we like to mention it. Don't really want to mention that. You go read that in your own time. It's not really that important. No, go read that. It's essentially to do with like sometimes if you're going to pass JSON through the query, you need to think about it differently. So if you're ever passing JSON through the HTTP query, go and read that. Yeah, so this is also, we're getting to the point where I'm just kind of leaving little disclaimers. This one here, we're basically just trying to say to you that not everything we teach in the course is like identical to something you might see in industry. As a good example, the status code 400 typically implies like the user made an error, like they gave bad input. Sometimes they'll return a different status code to trick people into, not trick people, but to like not give too much away about how the system works. You'll see this sometimes in, industry. Also, industry doesn't always take the meaning of post, put, get, and delete literally. You'll see a lot in industry where they'll make an HTTP request where something is actually being created behind the scenes, but they'll still use a GET request or a PUT request. So just back on that CRUD thing with GET, POST, PUT, DELETE, they're really indicative in general communication methods. They're not like something that people always adhere to spot on. Very last thing here. There is a great tool called NodeMon. You can go and install it yourself. It's great for the server side of things. So let's say here I've got my server. I'm going to go and install it. And what you can do is that when instead of running npm run tsnode, what was it called? crud.ts, right? You should be able to instead do npm run nodemon crud.ts. And I think you do have to include it here. We've included it for you in this particular example. But this is a great little library. And what it does for you is it basically means whenever you hit save on your file, it will restart the server for you. So let's say I write, your name can't be empty at all, ! I hit save. It detects the file system changes and it restarts your server for you. It's a really great development tool for people like you to work with, because when you go and make little changes to your server, it will detect it and restart it, so you don't either have to go and constantly restart it, which is annoying, or forget to restart it. And there's been a lot of times I've worked on a server where I've needed to restart it, but I forget to restart it, and then I'm like, oh, why isn't it working? And then I just get caught in a loop. So go check that out as well. And lastly, this is just a cute little other byte Go image that kind of shows you the difference between an API and an SDK, because you'll hear about APIs sometimes and you'll also hear about SDKs. APIs are just documentation regarding a service that you can talk to, whereas SDKs are actually full-on kits that you build stuff with, So think of an API like basically, information about different numbers you can call and different things you can say to get different things back. Whereas SDKs, if you see them in the workforce, we don't talk about them in this case, but they're basically where someone gives you like a toolbox so you can build stuff with it. So they're like, hey, here's a set of tools that you can go and make your own thing with a lot easily, because I have seen students get confused between those two. Anyway, that's it. We got a couple minutes left, so if you have any lingering questions, let me know, but we'll wrap up in a couple of minutes regardless. Cool. If anyone's typing really slowly and just hasn't gotten around to it and it takes a while to come, I'm really sorry. But I'll call it there. I'll just assume we don't have many questions. Otherwise, post on the forum. Thank you for coming. Hope that was insightful. Don't be afraid to watch this again. A lot of students do. So thanks, everyone.